Hello everyone, thank you for checking this video. In this video, we'll be talking about operator overloading in C++. Operator overloading in C++ is a special feature that programmers use when they need to use certain kind of symbols such as plus sign, minus sign, and many others to define the functionality for their own custom data type. For example, if you want to add two complex numbers where the complex number is the class that we have created in our last video, in that case the plus operator doesn't know how to perform the addition. In these scenarios, we need to overload that plus operator symbol, and it is where operator overloading comes into play. So if we want to overload the plus operator to add two complex numbers, we need to have a separate function of type like this, where the function signature will have the format as shown here. The function signature should have a return type, then a keyword, then the symbol that we want to overload, and then the input types. The input types are nothing but the two complex numbers, suppose, that we want to add. So overall, the function signature for the operator overloading for plus symbol would look like this. So suppose we want to add two point2d variables. The type is point2d and the variables are x and y. So this function signature has inputs x and y, and those x and y variables are inputted as reference, and then the return type is also a point2d, because when we add these two variables x and y, we get another point2d type variable and we return that. So return type is also point2d here. Then we use the operator keyword. That's the keyword that we use when we perform operator overloading. And then the symbol plus, because this is the symbol that we want to overload, because we want to add two point2d type variables x and y. So this is the overall function signature that we'll be using across multiple symbols. So we can have a negative symbol here, we can have two equal signs here, and many other symbols that are available in C++. This is the class that we had created in our last video. The class name was complex CLS, and this is the header file that we prepared last time in our video, and this was the CPP file where all the implementation of the different class methods were developed. Now what we want to do, we want to test how we can create the operator overloading function for this class, and then we also want to test whether the operator overloading function is working or not. So for that, just for the testing whether without the operator overloading can we still perform the addition operation with the complex num data type or not, so we'll just create another object and suppose the name of the object is, suppose, cnum4, and this object is created as 5 and 5 are the real and imaginary values for that complex number. Now suppose we want to test whether plus operator works on this cplx data type. So for that we'll create another variable cplxnum, and Name of the variable is suppose cnum5, and that is obtained by addition of cnum2 and cnum4. And now suppose if we want to compile the code, what do we get? As you can see that we are getting bunch of complaints, and it says no match for operator plus. So that means we do not have any kind of implementation of this plus operator that can operate on C complex num data types. As we have discussed before, we need to overload this operator, and for that we'll be creating a plus operator overloading function, as I am going to show you now. So for that we'll be creating a function. The signature of that function will be like this: first the return type, and then the keyword operator, then the symbol plus, and then we start our parenthesis, then I say const, just to ensure that we are not changing any of the variables that we will be adding. So in this case, other is the second complex number type variable on the right hand side of the plus operator. We just take that variable as input and will not change any of the content of that variable. And also we want this function to not change any other functionalities of the class. So we have another const here. So this is just a function signature which we need to define in the header file, and then we have to implement that in this CPP file. When we implement that in CPP file, we will just need to copy this because the signature will remain the same, except the part that we need to specify which class this function belongs to. So we have this created here. Next, what we want is we'll create two integers, suppose int real new, because this is the variable which will contain the new real number for after what we for the variable what we get after the addition is done. And this new real number will be the sum of the real number of the complex type variable, which is left side of the plus operator. In this case, that will be identified by the this pointer, and then we invoke the get real method, and then the real part of the other variable. We will have same thing for the imaginary part, except the difference is now we need to call this get img method. Okay, so now that we have the new real and imaginary value of the return type complex number variable, we just need to return a complex number type object whose real part is real underscore new and the imaginary part is img underscore new, and that is it. So we now have the plus operator overloaded for this complex num class, and let's see if we now can compile. Okay, so we got error because we did not specify the type of this other variable in the function signature and also in its the implementation in the CPP file. So we now have corrected this, and let's see now can we compile the code or not. And the code compiles. Now let's run the code and see whether we have the right output. But before that, in order to see the output, we need to invoke the print method for the cnum5 variable. And once we compile that, let's now see the output, and we see that yes, so the plus operator is now overloaded. It performed the addition of the two complex number properly. So it added cnum2 and cnum4, and the real part is now 8 and 5, which is 13, and the imaginary part is the sum of 5 and 5, so which is 10. So we are getting right results here. Now we will check another example. In operator overloading for the two left shift operator has a special significance. We use these two left shift operator to print a variable. However, C++ knows how to print those variables, or standard cout knows how to print a particular type of variable if the data type is previously known to cout. However, if you have created your own data type, then cout doesn't know how to print that. In that cases, we want to overload these left shift operators, and we need to overload this operator. In other words, what we want is that we have a custom data type, and data is the variable name of that custom data type that we have created, and we want to use cout to print the contents of this variable data, which is of custom data type. In that case, the overloading function signature for the left shift operator would look like something as presented here. As you can see, the return type for this function signature is OStream, and then we have again the keyword operator. We also have this symbol that we want to overload, in this case left shift operator, and this function takes two input variables. The first one again is stream, which is of type OStream, and the second one is the point pt, which is of type point2d. So in this case, the stream variable is nothing but the cout, which is of type OStream, and pt is nothing but suppose the data that we want to print. I hope this is clear. Next we'll see an example. Now let's overload the left shift operator for printing a complex number type variable. And in order to do that, we again come to this complex cls.cpp file, and there we'll be creating the function for overloading the left shift operator, which will then print any complex class data type variable. However, we want this function to be implemented as a friend function of the complex class, and we'll do it in the following way. So the output type, as we have already explained, for this overloading function will be of OStream. Then we use the operator keyword, then we use the symbol, then we say OStream this stream variable is nothing but cout, and then complex number, and then other. Other is nothing but the name of the variable of complex number type. Now what we do is we'll create stream like this. Stream left shift operator other, then get real. So then we'll use a comma between the real part and imaginary part, and we'll invoke im get img method. Once we have that, we'll just return stream, and we need the reference of the return variable here. And next we'll come to the header file of complex class, and we'll type friend because we want this function to be the friend function of this class, complex class. For that, we now just copy the function signature from here. I copy this and put here. We now get back to our main function, and we will comment this out because cplx print was the function that we were using for printing complex number variables. However, we'll now be using more usual method because we have now overloaded the left shift operator. So we'll type the name of the variable that we want to be printed, and that completes the implementation of the overloading of the left shift operator for printing complex variable. Now let's see whether the code compiles. Yes, it does, and we just now need to print run the output. As we can see that we have this 13,10 printed here after, since now that we have this left shift operator overloaded. I hope this is helpful. Okay, so we have seen a couple of examples where we have overloaded different operators to be used with the custom data type of or the class that we have created ourselves. However, the symbols that we have used so far in this video are the plus and left shift operator. However, we can overload any other symbols like plus, minus, asterisk, division, is equal to, not is equal to, and many more. Further, I would try to make you aware about that the fact that operator overloading is useful only when it's actually needed. If you do not need operator overloading, do not overload any symbol. That way your code would look much simpler. Operator overload is useful when you have some arithmetic operation going on or some printing operation that you want to do, or in cases where you want your custom made class has the functionalities such that using operator overloading will make your code look much cleaner and easy to read. And these are the only cases operator overloading is useful. On the other hand, some programmers prefer to define the same functionality using operator overloading and using a separate function. For example, if you want to add 2.2D type variables, you can definitely use the operator overloading using the plus sign. At the same time, you can have a separate function called add, and that would take 2 points, 0.2D variable data1 and data2 and would perform the same function, and now it's up to the user about his or her preference which function he or she wants to invoke. So when you are designing the API for your class, you may have both these functions present there, and then it's up to the user who wants to use which function. I hope that makes sense. With that, I would complete today's video and hope to see you in next one. Thank you.